Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 109th of physics. Today we are going to discuss question number 4. Let us understand first the question. The diagram shows two metal spheres mounted on portable insulating supports. A student is given a glass rod and a piece of silk. Without allowing any contact between the glass rod or silk piece with any of these spheres, describe how the student can charge the two spheres with equal but opposite charges. There are few steps in which we can describe this phenomena. First, the student will rub the glass rod with the silk cloth. The rod will be positively charged and the cloth will become negatively charged. A positively charged rod is brought near to sphere A, as you can see that in the figure. This causes the protons to be repelled to the farthest side of the sphere B. Under this condition, sphere A alone will have excess negative charges and sphere B will have excess positive charges. Now the third step is, with the negatively charged rod in place, the two spheres are now separated a distance apart using insulating stands. Now the fourth step is, the sphere A will now have induced negative charges while B will carry an equal number of induced positive charges. Now remove the charge rod. After the separation, you have to remove the charged glass rod. Now before separating, if you are removing the charge, then the spheres will not be charged oppositely and equal. After the removal of these spheres which are in contact with each other, then the spheres will be charged oppositely, and as a result we will get equal charges as well. Now let's talk about the question number 5. Question number 5 is in A part, saying explain why it is possible for an air passenger to get an electrical shock when he touches the knob of the toilet door in a high altitude flying aeroplane. Now, when the aeroplane is passing through air, the body of the aeroplane is charged electrostatically by rubbing the surface of the aeroplane and the air particles. When the passenger touches the knob, the charge will flow to the ground of the aeroplane through his body, and in this way he will get electrical shock. Now in B part, they are saying, why do some car owners fix to their cars a piece of fine chain when drags on the road? You can see those chains behind the trucks as well, which is touching the road. When the body of the truck is passing through the air due to rubbing, the body of the truck is charged electrostatically, and if these charges are not removed from the body of the truck, then the driver and the other people inside that truck or car will get electrical shock. Now to remove these charges and neutralize the body of the truck, there are fine chains hanging from the body of the truck and which is touching the earth. The purpose of this is to neutralize the charges of the body, and as a result the passenger as well as the driver will not be shocked. So both the A and B part are pointing to the same concept. Very technically, those chains are called dangles. So now let's turn our focus to question number 6. Now question number 6 saying two small light balls coated in metallic paint are suspended by long insulating threads from point A and B as shown in the figure. The first part is asking both balls are given a positive charge. Remember, both are having the same charges. Complete the figure below to show the new position of the balls and their suspending threads. Now, in this case, you have to observe the separation because A and B are close to each other and they are putting a force of repulsion on each other. Because the force of repulsion will be greater, so they will separate more, as you can see in the figure by the red lines. They are separated in opposite direction because similar charges repel each other. Now in the second part they are saying that very carefully the sphere of point B is carried to point C. Now the distance is more, so they will affect each other less, and as a result there will be a less repulsion between thread sphere A and sphere C, as you can see in the figure. Dear learners, this theta and this theta will be larger as compared to this theta. If we are dragging it with this line, so this theta will, so the separation will be a smaller one. Why? Because the distance is now longer, so the distance of separation will be a smaller one. In both cases they will repel each other, but in the first case they will repel each other with the larger distance, and in the second case they will repel each other with a smaller distance. Now the final question of this exercise is question number 7. A light conducting sphere, positively charged, remember, hangs vertically on an insulating thread. When a metal plate on an insulating stand is brought near, the sphere is immediately deflected as shown in the diagram. This is question number 7. There is also a question number 8 is there. So this is not the final question. Part number A is saying explain why the sphere moves immediately to the new position. When a metallic plate on an insulating stand is brought near, the sphere immediately deflected due to the repulsion, because similar charges repel each other, and you can see that the positively charged conducting sphere is repelled. It shows that the metal plate is also positively charged. Now the B part is saying how does the movement of the ball illustrate the meaning of the term electric field. Now the definition of the electric field is the area around a charged body in which another charged body can feel a force of attraction or repulsion on it. So that is called electric field. Now because the sphere is in the electric field of the metal plate is coming to the electric field, just like there is an electric field. I am showing that electric field in the shape of concentric circles. When this metal plate is brought inside this electric field, so this sphere will feel a force of repulsion on itself, and as a result it will move away. If this metal plate is outside the electric field, the metal sphere will not feel any force on itself and it will be stationary. So electric field in this context is showing that the electric field around the positively charged conducting sphere is such that the metallic plate is inside that field, and as a result they deflect each other. Now let us turn our focus to the question number 8. The diagram shows a negatively charged metal sphere held with an insulating handle. As you can see, there is a blue insulating handle and there is a sphere which is negatively charged. There is a metallic plate which is shown in black. That metallic plate is attached to the earth passing through galvanometer. Now galvanometer is a device which is used to detect the current, not measuring the current. Current, what is current? That is our next chapter, but current is the flow of charges. One is conventional current, that is due to the positive charges, and one is the non-conventional current, that is due to the negative charges. We will discuss that in the next chapter and we will start that tomorrow. So here, when this negatively charged sphere is brought near to this metal plate, positive charges will be attracted and negative charges will be deflected to the farthest side of this metal rod. Now from the earth, a positive charge will be moving in this direction to neutralize these negative charges from the earth. So this pointer will show a deflection like this, but that will be a momentary deflection, not a permanent deflection. For a short interval of time it will show deflection, and not for longer time. It will again come back to its zero position very quickly. Now in the B part they are asking how could a deflection of the galvanometer pointer in the opposite direction to be produced. Now to produce this direction we have to charge this metallic sphere is positively charged. So then negative charges will be attracted from that neutral metallic plate, and then positive charges will move to the farthest side. Now these positive charges will move towards the earth to neutralize. So when the direction is changed, the direction of deflection will also be in this direction. So when it is negatively charged, this metallic sphere, the galvanometer will show a deflection in one direction. When the metallic sphere is positively charged, the galvanometer will show deflection in another direction. The C part is saying why is there no deflection of the galvanometer pointer if the metal sphere is held in the hand and moved towards the metal plate. Now when you get this metal sphere in your hand, so the negative charges will be neutralized through our bodies with the positive charges coming towards this negatively charged sphere. And when it is neutralized, then the plate will not show its behavior of charging, because this sphere is already neutralized. It means no excess charges are there. So the galvanometer will neither show deflection in one direction or in another direction. The nutshell is the charges will flow through the hands, and no deflection will be shown on the galvanometer. That's it. And with this we came to the end of this topic. Tomorrow we will start another topic, and that is with the name of current electricity. That is very important. Stick to this channel. Thank you very much for your time. Allah Hafiz.